Hello. Hello. Abdul. Is it audible? Hello. 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 Abdul.
Yeah, ma'am, you're audible.
Yeah, right. Thank you. Thank you for your confirmation.
Okay, ma'am.
Shall we start the class?
Yes, ma'am. Sure.
Okay, right. Right. In this module, we are going to discuss about three things. Those three are classes, objects, and methods. Right. So here we are going to see what are the class fundamentals and declaring the objects, how to declare the objects, and how we are going to take the reference variables and how the assignments can be done, and how to declare methods and how to return values from the methods, and using the parameters in the methods, and also constructors, parameterized constructors. Sometimes we have the default constructors and non-parameterized constructors, and parameterized constructors also, and how we can use the keyword this in Java. And also we are going to talk about scanner class and also garbage collection. So all these and finalizement, garbage collection including finalizement. So these are all the topics that we are going to discuss here in this module. Right now, first we are going to see about classes, objects, and methods. Now, what is a Java class? So here you can say that a Java class is a set of objects. A Java class is a set of objects which shares common characteristics or common properties. Generally, we give a definition for the class as like this. A class is a set of objects which shares the common behaviors or common characteristics and common properties. Now, class is not a real world entity, that is, it is not a physical entity. A class is a logical entity. Always it is a logical entity. That is, whenever we created a class in Java program, it will not get any memory space, right? Since it is a logical entity. It is just a template or blueprint or prototype from which objects can be created. So here, this is the real world object. This is the blueprint for that particular object. So this is to be called as class and this is to be called as object. Right. Now, class consists of a group of variables with different data types and a group of methods. So here, what I said you as an example, suppose if we want to create a car, so first we need to require a blueprint. That blueprint itself is to be called as class. From this blueprint, we can create the object, which is nothing but car, right? So here, finally, how I can say a class? A class is simply how I can define a class. A class is a set of or collection of objects which shares common attributes or common characteristics and common properties, right? It is not a real world entity. It is a logical entity, right? It is a blueprint for the object that I want to create, right? And coming to the next one, objects. Now here we are seeing some examples for the classes. So here, class human. What may be the objects for that class? Man, woman, child. All these are the objects for the class human. Next, fruit, apple, mango, banana. All these are the examples for fruit. That is objects for fruits. phone. Different types of phones will be there. iPhone, Samsung, Nokia, like that. And food, different types of foods may be there. Pizzas, burger, and rice, etc. Right. Now, always a class contains two things. One is data members and methods. Data members are nothing but characteristics. Whatever the characteristics we are taking, those characteristics are to be called as data members, and methods. Methods are nothing but the attributes. Whatever the attributes we are taking, those attributes are nothing but the methods. Right. Now, how to write a class? A class can be written as like this. So always we need to use a keyword class. After this keyword, we need to write the class name. Whatever the things that I want to represent within the class, those should be written within a block. This is within these curly braces I need to write, which is to be called as class body. Right. Now here I am going to write a class person. Now here this represents an access specifier. So whenever I need access specification, sometimes I need private classes, sometimes I need public classes, sometimes I need protected, like that. Whenever I need the access specifiers, I can use these access specifiers. Otherwise, no need of using access specifiers. By default, default access specifiers will be there here. Now, class person, here class is a keyword, person is the name of the class, and here I am going to write the characteristics or behaviors. Now, here you can see name of the person. What is the name of the person? And here I am going to write the attributes or the methods, print name. So here I want to print the name of that particular person. So like this, I can write a class, right? Suppose, for example, if you want to write a class for car, so whatever the example we seen there. Now, how I can write a class for car? So here you can see that class car. So here, whatever the parameters that I have, so here I am writing that string color of the car, right? And int model number, right? Two characteristics I am writing, right? Now, I am going to write model void speed of the car, void speed of the car, and I want to print its speed value. I want to print its speed value, right? Now, here I can close. This is writing of a class for car. So, these are all the characteristics. These are the behaviors or methods, right? Next, we are going to see an object. What is an object? Objects are instances of classes that encapsulate data and behavior. How my class is present? In the same way, object can be present. Object contains, since object as an instance of class, it contains whatever the data and whatever the behavior we represented in the class, those can be represented to the objects as well. Right. Here, the objects are the real life entities, real world entities. Whereas our class is a logical entity. There is no any physical space given to the class in the memory. But for object, we have a physical space in the memory. Right. And an object consists of its state, behavior, and identity. Identity is nothing but, so suppose for example, if you are taking a class dog, right? Now, name of the dog is to be called as its identity. State and attributes. What is the breed of the dog? What is the age of the dog? And what is the color of the dog? That particular dog, right? That is to be called as its attributes or states. And behaviors means how it barks, how it sleeps, how it eats, right? So all these are the behaviors of that particular dog, right? So this is a way of writing. This is an object. So simply saying how a class can be defined. A class can be defined as class is collection of objects. Class is collection of objects. How an object can be defined? Object is an instance of class. Object is an instance of class, right? Now, next, so we can see how an object can be created. How an object can be created for a class. Now, here, this is the syntax that what we follow for creating an object. Now, what is the syntax here? Let us see. Class name, object name is equal to new is the keyword that what I want to use. Here, that particular class constructor that I need to write. Here, this is to be called as constructor. After class name, if you are writing parentheses, this is to be called as constructor, right? Now, the new operator. So here you can see the new operator instantiates a class by allocating some memory. I already said you that class doesn't have memory, but whenever I create an object, that object contains some memory, right? So now, how object is created? So whatever the new operator we are taking here, that new operator instantiates a class by allocating memory for a new object and returning a reference to that memory. It refers that a reference to that memory. And the new operator also invokes the class constructor by default. So this is the class constructor. This can be automatically invoked by the new operator, right? So here, for example, they given bicycle is the name of the class. Sports bicycle is the name of the object is equal to new bicycle. Bicycle is the name of the class. Touring bicycle is another object and new bicycle. So class name, object name, keyword and class constructor, right? So here for a bicycle class, here I created two objects, two instances we have taken. It is a bicycle. It may be a sports bicycle or it may be a touring bicycle, right? So two types of bicycles are there. These two are the objects, right? Now here in the same way, you can see the example, class dog. So here dog 1, dog 2, dog 3 and dog 4. These four are the objects for this class dog. So every dog is having all these attributes and all these behavior. Dog 1, its breed, its age, its color. Dog 2 is having its own breed, its age and its color. In the same way, dog 3 and dog 4. Every dog is having its own behavior, right? So this is the way of writing an object, right? And accessing the members of a class. So after creating the object, how the members of a class can be accessed. Here we use this dot operator to access the members of a class. So here you can see that I have written a class bicycle. Now here we have written int gear is equal to 5. This is the data member of that class. Void breaking. This is the behavior of that class. That is the method what we written in that class. Now here I am going to create an object for that class. So here what is the class name? Bicycle. Same class name here we are using. Here we are writing the object name. Any valid identifier becomes the object name. That is equal to new bicycle. Right. Now here how I can access this variable object name dot gear. What is whatever the parameter that I want to access. So how I can access the parameters of the a class? Object name dot variable name. Whatever the variable I want to access, that variable name. Suppose if I want to access the method, how I can access? Object name dot method name. Object name dot method name. Right. So here you can see sports vehicle dot breaking. This is a method name. Right. So like this, I can access the class members by using an object. Suppose, for example, simply I want to write a small program. So how it writes a class, how it creates an object, how it accesses the data members, right? So simply you can see the example program, class. So here I am going to take a class named, yes. Sorry, 1 minute. So here I'm going to take a class X, let us say. Now, here my class contains some variable value. Variable 1 is equal to 10. And I have one more variable, int variable 2 is equal to 20, right? And here I have some other variable, let us say sum, right? And here I am creating a method, just say method 1, right? Now, in this method, I'm going to find sum is equal to variable 1 plus variable 2, right? Now, here I want to print that sum value. So here I am writing printing of that sum value. I close the method. Right? Now I want to access these numbers by creating an object, right? Now, how I can write that? So here we are taking main method. So here we are writing a method. So here we are writing main method, right? Now, here in this, I'm going to create the object for my class. Here, this is class name. I'm taking just object 1 is equal to new class constructor, right? So here I created an object with this name. Now, how I can access these variables? So here I'm going to write print statement. I want to print object 1 dot variable 1 value. Now, system dot out dot println. I want to print object 1 dot variable 2 value. Right. Now, I want to access the method 1. I want to access the method 1. Right. Now, how I can access the method 1? Object 1 dot method 1. Right. Now, main method closed, my class closed. So, when I run this program, what becomes the output of this program? Right. So, first the execution starts from the main method. First, it creates an object for the class, right? So, after that, it accesses the variable 1 by using this object. It accesses the variable 1 from this class. So, that's variable 1 value will be printed. Now, here 10 will be printed. Next, variable 2 will be accessed, whose value is 20. Now, that can be printed here. Variable 2 value can be printed here. After that, it accesses the method. Here, the method is present. This method finds the sum value and sum value is printed. Now, the sum value is printed as like this. Right. So, this is the way of writing an entire program in Java by taking classes and objects into the consideration. Right. Now, let us see the next one, methods. Right. Now, just now we written a method simply as void method 1. Like this, we written a method, right? Simply we written a method, right? Now, not only this is the way of writing the methods, we have different ways of writing the methods. Now, what are all those different ways? What are the various things that are present in the methods? All these things that we are going to see here. Now, first of all, what is a method? A method is a block of code or collection of statements or set of code grouped together to form or to perform a certain task or operation. So here it is generally a behavior which defines the behavior of a class, right? So we write a method once and use it for many times. Wherever we want to use that method can be used, right? So the method is executed when we call or invoke it. Whenever we invoked or whenever we called the method using object name, then only the method can be executed. Otherwise, it cannot be executed. Now here you can see the structure of writing a method. So here I need to if it is necessary, we need to write the access specifier of the method and the return type of the method, name of the method, and the parameters list of the method, and body of the method, right? So this entirely is to be called as method header. This entirely is to be called as method body or method signature, right? Now here, what are all these things? Access specifier. Access specifier tells where that method can be accessed. If it is public, it can be accessed anywhere. If it is private, it can be accessed within that class only, like that. So some access specifiers are there for every method. We can use those access specifiers to restrict the use of that method, right? And the return type. Earlier, we have written the return type as void. That is, we are not returning anything to the method. But here we have represented it as int. Now that is from this method, we are going to return an integer value. That is indicated by this return type, right? And method name. So any valid identifier can be taken as the method name. And I may pass some number of parameters to my method. So while writing the parameters, I need to represent the data type as well, right? Entirely, this is to be called as method header. So whatever the implementations that I want to write within the method, those implementations can be represented within the method body or signature, whatever the operations. Earlier I represented some operation will taken. We performed addition operation. So that can be represented within the body of the method, right? Now, next. So here, what are the types of methods that we have? So we have some predefined methods and we have some user-defined methods. Predefined methods means in Java, some class libraries, they may itself have some predefined methods. That is, we are not writing the logic belongs to those methods. So when the Java is developed, at that time only those methods were developed, right? Built-in methods. Those are also called as built-in methods. Some methods that are length, equals, compared to, square root, all these are the various methods, predefined methods, right? And coming to user-defined method, whatever the method that I want to write, that a particular user wants to write, that is to be called as user-defined method. So here you can see an example for user-defined method. I want to write a method, find even or odd. That is the name of my method. Now I want to write this method. That's why I have done like this. Now here you can see, this is the access specifier. I want to make it as a static method. That's why I written it as a static. And this is the return type of the method, void. This method is not returning anything. Just here itself, I am printing the values. That's why we are not returning. And this is the name of the method. And here we are passing the parameters. So here we are passing an integer parameter we are passing. Now here this method finds whether the given number is even or odd. So that's why we are doing the modulo division of given number with 2. When I am getting the reminder as 0, that becomes even. Else, if it is false, we come into the else. This prints the number is odd. So like this, we can write whatever the logic that I want to write within the method, that logic can be represented here in the method body, right? So this is about the methods, how I can write. And coming to the constructors, what is a constructor? Now here you need to know what is the difference between method and constructor, right? Here, a constructor is a block of code which is very similar to method, Now, when an instance of class is created, that is when an object is created. What is instance of class? This is nothing but object. When an object is created, this constructor will be called. So at the time of calling constructor, memory for the object is allocated. Whenever the constructor is called, whenever we created the object, the constructor is called. Whenever the constructor is called, memory for that particular object is allocated, right? So we can say that it is a special type of method used to initialize the object. That is whatever the parameters that we have in the class, for initializing those parameter values, we can use this constructor. Right. Now, every time an object is created, we are using the keyword new, right? Which is nothing but at least one constructor that we are creating for our class, right? Always the new keyword calls it default constructor. Default constructor. If there is no any constructor, a default constructor will be executed by the compiler, right? Now here, what is the difference for method and constructor? It is very similar to method. So what is the difference between method and constructor? Constructor is having the same name as class. Whatever the class name you have taken, the same name should be given to the constructor also. But method doesn't have the same name as the class, right? That is the main difference. And one more difference is, generally constructor is used to initialize the values, parameter values. But method for not. Method is used for writing the behavior of the class, right? The various logics we can write in the method, right? Now, next. So here there are two types of constructors in Java. So first one are the no argument constructors and parameterized constructors. So we have two types of constructors, no argument constructor and parameterized constructor. But if we not written any constructor, whenever I created an object with the new keyword, that new keyword automatically invokes a default constructor, right? So now we are going to see what about this no argument constructor and parameterized constructor, right? Now let us see what are the rules that we need to follow for creating a constructor, right? That we need to see. Now, why we are calling it as a constructor? Because it constructs the values at the time of object creation. Whenever we are creating the object, at that time it is constructing the values. That's why we are calling it as a constructor. Okay, it is not necessary to write a constructor for a class, right? No need of writing. Definitely we should write the constructor like that. So there is no need. There is no thumb rule for writing a constructor, right? It is because Java compiler creates a default constructor whenever an object is created, right? Now, what are the main rules that we need to follow? Constructor name must be same as the class name. Constructor must have no explicit return types. Java constructor cannot be abstract or static or final or synchronized. But a method should have a different name other than the class, and it should have some return type. If there is no any return value, at least I need to represent the return type as void. And a method may be abstract, a method may be static, a method may be final, and a method may be synchronized. But constructor may not always. A constructor cannot be an abstract, constructor cannot be a static one, constructor cannot be final, and constructor cannot be synchronized, right? And constructor should have the same name as class, right? And it is not having any explicit return types. Now let us see how the constructor can be created. So here you can see class test. This is my class. For this class, how I can create a constructor? Whatever the name I have with the class, with the same name, I can create the constructor test, but it should be represented with the parenthesis, right? So, and constructor body, whatever the body that I want to write here I can use it. And there is no any return type for the constructor, right? Next, so I already said you that we have three types of constructors: no argument constructors, default constructors, and parameterized constructors. What about these types of constructors? No argument constructors. That is, it is not taking any arguments. The constructor is not taking any arguments. That is to be called as no argument constructor, or we are not passing any parameters to the constructor. That is to be called as no argument constructor. So just we write, we can write it as, this is the access specifier. We may write or may not write. This is the constructor. How we write a constructor. Whatever the body I want to write, within the block I need to write that body. Right. Now class main. So here we have taken a variable I. Now this is the access specifier. This may write or may not be written. Now I want to write the constructor. Now whatever the class name that I have, with the same name I need to write the constructor. So main is my constructor. Now within this main I want to write I is equal to 5. Whatever the I variable I have taken here, that value is assigned with 5. And here I want to print a statement constructor is called. Right. And here whenever I created an object for this class, by default, the constructor can be invoked. That is, it invokes this constructor. Right. Now, what the output of this particular program? So first, since the constructor is invoked, this is invoked, and here first it prints this statement. So what the statement it prints? Constructor is called. This statement is printed. After that, this statement will be printed. So what it brings? Value of I. So what is the value of I? 5. That can be printed. Right. So this is a no argument constructor. That is, here we are not passing any argument to the constructors. That's why it is to be called as no argument constructor. Right. Next. If we want to create objects outside the class, then we need to declare the constructor as public. Right. Suppose here in this case, I am creating an object within the class itself. So within the same class, I created the object. But if I want to create the object and I want to access the constructor should always be public. So here you can see class company, string name, public company is the name of the constructor. Here I initialized that name with the program is. Now here I have taken another class. Here I want to create the object. Here in this class I am not creating the object. Right. Here we have taken separate class for writing the main method. In that I want to create the object. Now how to create the object? Class name, object name is equal to new class constructor. Right. So what is my class? Company object. Object name I am taking it as obj only is equal to new company. Right. So like this I can write the constructor. So all these are all the no argument constructors. Here also we are not passing any parameters. Right. And second one is parameterized constructor. Right. If I pass parameters to the constructors, how it will be? So here you can see class main, string languages, main, string lang. Now, whatever the variable that I am taking lang here, that value I want to assign to these languages. So that's why here languages is equal to lang. Now I want to print whatever the languages that it taken. Right. Now here I have the main method. Now I created an object for the main method. Now I have created another object for the main class. Now I have created another object for this main class. Right. Now, what will be the first when this object is invoked? When this object is invoked, what becomes the output of the program? So when this object is invoked, this will be invoked. Now, whatever the lang value here, Java is the lang value I given. That lang value is assigned to languages, and this will be printed. Now, what it prints? Java programming language, like that it prints. And whenever I call this object, so this also invokes its method automatically. Then what will be printed? Python programming language, right? And C. Here, when I invoke this constructor, what will be printed? C Programming language. C programming language. Right. So like this, the parameterized constructor will work. Now default constructor, if there is no any explicitly written constructor, the default constructor is invoked. Right. Here I not written any constructor explicitly. So whenever I created an object, the default constructor is created. Right. Now whatever the values I assign to this, those values can be printed here. Right. Now these three are the different types of constructors that we have. So what are the three different types of constructors? Default constructor, no argument constructor, and parameterized constructor. Right. Now coming to this keyword. So what is the purpose of using this keyword in Java? So generally, this keyword is used to refer the current class variables. Whatever the current class variables are there, whatever the current class methods are there, for accessing those current class variables and current class methods, this keyword can be used, right? So here you can see that the keyword this can be used to refer current class instance variables. This can be used to invoke current class method. This can be used to invoke current class constructor. But in this way, I need to use, right? This can be passed as an argument in the method call. So whenever I return a method, so I can pass this as an argument. This can be passed as an argument in the constructor call as well, right? Within the constructor also we can pass as an argument, and this can be used to return the current class instance from the method. From the method for returning current class instance also we can use this keyword. Now we will see all these points with examples, right? Now here this a reference variable, it represents the current class state and current class behavior, right? Now here you can see an example when if I am not using this keyword, what happens? So here you can say this is a class student. We have three variables in this: roll number, name, and fee. These three are the variables that I have in the class. Now here I return a parameterized constructor with the same name, right? Which contains three parameters: roll number, name, and fee. The same values that I have taken. Now, whatever the roll number I am taking here, that should be assigned to here. Whatever the name I am taking here, that should be assigned to this one. Whatever the fee I am taking, that should be assigned to this one. That is my aim. So that's why instance variable. This is the instance variable. This is the parameter, constructor parameter. Constructor parameter value is assigned to instance variable. In the same way here also. In the same way here also, right? Now, void display, this is a method that I want to write. In this method, I want to print roll number, name, and fee, right? Now, here I am taking another class. Within this, I am writing the main method. Now, student S1 is equal to, here what I am calling new student of. Now, three parameters are there in my constructor, right? Roll number, name, fee. In the same order, I need to write. Here, this is the roll number, this is the name, and this is the fee, right? And I created another object S2, that is, let us say student 2, roll number, name, and fee, right? Now I want to ask for displaying S1 dot display and S2 dot display. Now the output is 0, null, 0.0. Why it be? Here I given the values. Actually, these values should be printed here, but I am not getting those values. Here my output is like this. Why? Because here the control is not taking this as the constructor parameter. It is taking this also as the instance variable. How it is taking this? The same thing, this also has the instance variable. Instance variable doesn't have any value. So the default values are printed here. Right. So I hope that you understand without this keyword, what is the problem here. Now we are writing the same program with this keyword. So here you can see roll number, name, fee. Now here also roll number, name, fee. Now this dot roll number is equal to roll number. Now in this case, this can be taken as the current class instance variable and this can be taken as the parameter from constructor. If current instance variable and parameter both are having same name, in that case it gets confusion, right? It is taking both as the parameters, not as the instance variables, right? So for taking instance variable, we are taking this keyword, right? Now here I want to access with the two different objects. Now, whatever the values we have in the objects, those values are printed. Then I call this method for both, right? So this is use of writing mainly constructor, this keyword, right? Now here you can see one more example with this keyword, right? In this case, no need of writing this keyword because here roll number, name and fee are instance variables. R, N and F are the parameters. There is a difference in the name. In this case, no need of writing this, right? If both are same, in that case only I need to use this keyword, right? Hope that you understand. Next, this which is used for current class constructor. This used for current class constructor. Now here you can see how this keyword can be used for writing current class constructor. So here class A is the constructor of that class, and this A is another constructor of the same class. Here I am writing this system dot out. Here we printed some x value, and here we taken class and we taken main method and we created an object for A with 10. Now what becomes the output of this program? Whenever I created an object, its constructor is invoked with the value 10. Since I given a parameter, the parameterized constructor is accessed. This one. This is the parameterized constructor. This can be accessed, right? Now, when this is accessed, in this it calls the default constructor. So, in the default constructor, we have a print statement hello A. That hello A is printed first. After that, it prints the value of x. So that x value is taken as 10, prints the value 10 later. Right. This becomes the output of this entire program. Right. Here, this is used to invoke the current class constructor. This is the current class constructor. This is invoked here. In the current class constructor itself, we are invoking this keyword. Right. Now, calling parameterized constructor from default constructor. How this can be used? So here, A is my constructor. Now, this of 5. Here I called the constructor. Now here I printed this statement. And here I have written a parameterized constructor. And its value is printed. Now I created an object. Now whenever I created an object with this constructor is invoked. In this case, what happens? This of 5. Again, we call the constructor of the same class. Here it is present with the value 5 I called. So what will be happen? 5 will be printed here. Then it prints hello A. Prints hello A. Like that, a parameterized constructor can be called in the default constructor. Right. Now here you can see that this constructor call. So here, how this can be used for constructor call. So here you can see we have taken a class student. We have three variables. Right, here we have taken constructor of that class. Now here we use this keyword for identifying the instance variable. Now here I called another constructor with 4 values. Now here you can see I have called it with 3 values: roll number, name, course. With these only I called it. But here I called this with 4 numbers. Right. Now these 3 values I want to get from this constructor. So this of roll number, name, course that I am calling here. That is, we are reusing the constructor. Whatever the constructor I have written here, this constructor is reused. And here I have one more variable fee that is assigned to this dot fee. Right. And finally, I want to print all these statements. Right. So what is the roll number? What is the name? What is the course? And what is the fee? Now, student when I called, so this contains only 3 parameters. I called it 3 parameters. The student 2, I called it 4 parameters. I called s1 dot display, h2 dot display. Whenever I called this s1 dot display and h2 dot display, it prints these 2 statements. This is the first statement. So when I called this s1 dot display, since it contains only 3 values, those 3 values are computed. Default 4th value is not there, so that's why it prints 0. And second, whenever I call this will be 0, right? Now this is another real usage of constructor call. And this can also be passed an argument to the method, right? So here you can see this m is my method. Here m is the method. So this can be passed as an argument to this method. Now what this says, whatever the object we are creating for that class, for this object that object we are calling here. Right, that object we are calling here. Right. So this can also be used, right, like this also. And we can pass this keyword in the constructor also. We can pass this keyword in the constructor also. Right, here you can see. Within the constructor also we are passing this keyword. Right. So like that, there are a lot of benefits are there of using this keyword. And here I can return type of the method can also be this keyword. Return type of the method can also be this keyword. Right. So here you can see. Here the return type of the method is this keyword. Right. So, these are all the benefits of using this keyword. Right. So after that we are going for garbage collection. Now, garbage collection is nothing but it is an automatic memory management feature in Java that helps in reclaiming memory occupied by the objects which are no longer in use. The objects which are not used currently and which are not in use from long time. So for removing the memory to those objects, the garbage collection process works automatically. Here, the Java's garbage collector runs in the background and identifies and free up the memory that is no longer reachable or referenced by any program. Now, how this garbage collection works? The Java virtual machine automatically identifies and collects the objects which are no longer reachable by the program. So it is worked based on the JVM, right? So here you can see the example. Generally, if you see the C programming, there is no automatic garbage collection. There we need to use a free function for freeing the memory and dynamic deallocate function for allocating the memory in C. But that not happens in case of Java. It will be done automatically, right? Now here you can see one example. I have an object S1 which sets the data 1 and 2, S2 which sets the data 3 and 4, right? In the memory, S1 is created some values and S2 created some values. Now, S1 and S2 are referring these variables A and B. Now, here you can see that I have written some more code here. Here, I have created student S3. I want to make S2 values are equivalent to S3. and I want to show S3 data. Now, whatever the S2 values present earlier, those S2 values are referenced by S3 also, right? So, these two values are referenced by two objects, right? And now here you can see, I made S2 is equal to null, and just I am showing S3 dot. So, here S2 is not pointing this one. Even though S2 is not pointing, S3 is pointing these values. So it will not be considered for garbage collection. It will not be considered for garbage collection. Now here what I am doing, I am making S3 also null. Now there is no reference for these values. S2 is not referring, S3 is also not referring. So since there are no any reference variables for this, the JVM automatically identifies these variables, and the JVM removes, that is garbage collection, automatic garbage collection can be invoked, right? And these can be removed from the memory. And here the finalize method is used to release all the resources used by the object before it is deleted or destroyed by the garbage collector. Suppose now generally garbage collector automatically manages the memory by removing the variables which are not in longer use, which are not having any reference, right? Suppose if I want to remove entire object completely, in that case, a finalize method is used. The finalize method in the object class is called by the garbage collector, right? Whenever the garbage collector want to remove any object from the memory, it calls the finalize method, right? Now, these two methods suggest to the JVM to run the garbage collector, system.gc runtime.get runtime.gc. These two methods are used to suggest JVM to run the garbage collector. So whenever the suggestion that garbage JVM gets, it may not be immediately executed, but it executed after some time, right? Now here you can see the example for garbage collection, right? Here main method object one is equal to null. Whenever object one is equal to null, garbage collector may run. So here we are calling the garbage collector system.gc. It itself calls whenever I call the garbage collector, it itself calls the finalize method. This finalize method relieves the method from the objects what I want to remove, right? Now coming to the lab programs, in this unit, you have two lab programs. One is on classes and objects, and the other is on constructors. Now I will show you how these lab programs can be executed, right? Now here you can see my window. So is it really visible, this window, my compiler?
Yes, ma'am. Yes,
Yeah. Yes, right. See here, I have a class with the name class objects example, right? Here I have written the main method. Now here scanner class I used since I want to input the data on my own. That's why I used the scanner class. Now here I created an object for the student class. Where my student class is present, here separately I written that student class. Class student, which contains three variables, name, age, grade, right? And this class is having a method display information which displays all these three values, the student name, the student age, and the student grade. These three values are printed. Now for this class, here I created an object, student 1 is equal to new student, first student. Now for my convenience, I printed this statement, enter student name. Now here I read the student name. Here I ask for enter student age. I read the student age. Here I ask for entering student grade. I read the grade. Now I want to print the student information by calling the display information method. Now scanner close. I want to close the scanner class here. Right. Now here I created one object. Right. If you want to create another object for the same class. How you can create another object for the same class? So here you can see, I want to create student2 object. Enter, here I am asking student2 name, right? Here I am asking student1 name, student1 age, student1 grade. Here I am asking student2 name, student2 age, student2 grade. I want to print the information of student2. Here I want to print the information of student1, right? Here I want to access the method of student1, right? Here I want to access the method for student1. Here I want to access the method for student2, right? Now I created only one class. With this class, I created how many objects? 2 objects. What are those 2 objects? Student1 is one object. Student2 is another object, right? Now, let us try to run the program, how it will be executed. Now, it asks for student1 name. Now, I entered student1 name. Now, it asks for student1 age. Now, I entered the age of student1. Now, it asks for grade of the student1. I entered the grade of the student1. Now, it printed the information. Let us see student1 information. So here something wrong we written. So here my code contains student2 information. That's why it printed student2 information. Name is this one, age is this one, grade is this one. Now here I ask for entering student2 name, student2 age. Right. Now here you can see student1 information I want to print. Right. Student2 class we created. Now here itself I want to create the object for student2. So here you can clearly understand. Here I created 2 objects, right? Student1 name and student2 name, right? Now here I want to read student1 name and student2 name immediately. And after that I want to read student1 age and student2 age immediately, right? Here I want to read student grade, right? Now, here I want to print student1 information and I want to print student2 information, right? Now, let us run the program. Now, student1 name, 8. Student2 name it asks. Yes. Student1 age, student2 age, student1 grade, student2 grade. Now here you can see the information. Student1 information printed and student2 information. So why it is printing null? Why it is printing null here? Why it is printing null here? Let me know, please. So these values are replaced with these values in the memory, right? That's why these values are printed. These values are printed as null, right? So whenever I created, so here you can see, this is the memory corresponding to student1. So here 3 locations are allocated. This is for name, this is for age, and this is for grade, right? Whenever I created 2 objects, these 2 objects are referring to 3, right? Now, first I entered this value. So first it comes here, right? After that I entered this value. Same variable in the same place it need to be stored. So it is replaced like this, right? That's why it is not taking any value, right? I hope that you understand. Next, coming to the next one. So second program gives the constructor example. Now here you can see, I have written a class car. which contains two attributes, make and model, and year also another attribute. And here you can see I have written a constructor for the car which contains same variables. So that's why here I used this keyword. This dot make is equal to make. This dot model is equal to model. This dot year is equal to year. So these three, which are the variables which are present to the left side of equal, these represents these three variables. Which are present at the right side, these represents these three parameters, right? Now, I want to print the information. Now, how can I access all these? By creating an object to this car. Now here, I have taken another class and main method. We created car1 and car2, two objects we created. So we taken first car is make is Toyota and its model is Camry and in the year 2022. Second car make is Honda and its model is Civic and in the year 2021. Right. Now I want to call the display information method for both the cars. Right. Now let us see run the program, how it works. Now here you can see car information, car1, make Toyota, model Camry, year 2022. In the same way, car2 information also. So both are printed, right? So these two are the example programs that for your lab programs, what the lab syllabus that you have, right? So I hope that you understand all these things. So any doubts? You have any doubts? Let me know.
No, ma'am. It's clear.
Okay, thank you. Thank you. Practicing, are you practicing?
Tried, ma'am, last week to run successfully.
Okay. Okay.
Examples what you gave, I tried.
Okay, okay. So try to practice these also. Constructors, using constructors, this keyword, and objects, creating methods, accessing methods, all these things. Try to practice
Yes.
all these.
Yes, ma'am.
Okay, thank you. Thank you. May I wind up the session?
Yes, ma'am. Thank you.
Thank you. Okay, bye.